Good evening, Shivam. Hello everyone. Are you able to see my screen? Hello. Am I audible?
Yes, you are audible. And
Okay. Okay. Are you able to see my screen also?
yes, I am able to speak.
Oh, okay. Hello everyone. Welcome to all of you into the seventh live interactive session for the course Artificial Intelligence and Machine Learning in Materials Engineering, which is being instructed by the Professor Kishan Vishwas on the NPTEL platform. I am Shivam Aggarwal, PMRF fellow at IIT Kanpur, and I am a TA for this course. So, in the last few weeks, we have discussed about the some supervised machine learning, about like uh, how the regression problem can be solved and how can be a classification problem can be solved, which kind of data we needed. But in that problems, we required data like which we prepared from the from any computation method, or we prepare our data by using some experiments, or we have uh, curated the data from the literature manually. But today we will discuss about this some other technique like which is called the NLP, and which is used to for the data mining process. Like uh, the data is curated by the machine on its own. Like there is no collection of the data by manual process. So what is the natural language processing? It is a kind of like just you here you can see this example, like just you give a command to the dog, but dog can't be able to understand your whole sentence. It is just about picking some keywords and understand according to that. Like just suppose you uh, you give a command to your dog like sit down, or and eat these things, or you making a large sentence, but your dog just catch a particular word and do behave according to that. Same kind of thing will be done in the natural language processing. Like just suppose you have a very large paragraph, but there is a some keywords which is required by you, and other things is just not like it's just not like your uh, that thing is not needed for to you. So how can we say natural language processing is a branch of the artificial intelligence that studies the interaction between the computer and human using the natural language. Same thing is done by using like when you give a command to your okay Google thing, and to the Siri, Alexa. So that kind of thing is also used by the natural language processing. The objective of the natural language processing is to read, decipher, understand, and make sense of the human language into a valuable manner. Like you are just giving a command by using the voice speech. So how can a machine understand that language? So natural language processing help to convert the unstructured data which is produced in majority of time to the structured data with the help of algorithm. That's the thing which we are going to use here. Like you have a lots of data. Like if we see into the literature, there is a lots of data which are uh, they are in a unstructured manner, like that is forming the some paragraph that is not tabulated, not in a structured way. So for that purpose, what you can do, so you can structure that data, but when you going for to structure that data by manually, that take a lots of time, and it is required a very huge amount of labor also, because there is a lots there's a very large data based into the literature. If we see any particular for any branch, what is the what does the NLP steps? Like as we told earlier, we will going to the last point, like which is convert to the unstructured data into a structured data. So these are the some steps in which NLP is work. First of all, that do the segmentation of the paragraph. Then it tokenize that sentences. Then it removes the stop words. Like you have a if you have a particular something some sentence, like there are the some words which have a kind of like of, for, the, a, that is not required for structurization of the data. Then there is a stemming. Stemming means like there are some words which are like the give, giving, given. So that has have the same meaning for the machine. And for the lemmatization, what is the lemmatization? Like just like there are the various forms for the B, like is, are, were, was, and the part of the speech tagging. What is this? Like you have a different figure of speech, like sorry, part of speech, like verb, noun, and subject, object. So that is called the part of speech, and that your machine tag those words from the sentence. Like this would be the noun, this would be the object, this would be the verb. Then there is a name entity tagging. Like our purpose is like we want the structured data. For that structured data, there should be the like just suppose it convert a data into a structured way. So there should be some labels like this is the this value are called will, like just suppose you are searching for the boiling point. So there would be the like a name for every boiling point temperature. There should be a name like boiling point. So that is the name entity tagging. So this is the segmentation, how the segmentation being done. Like segmentation in the NLP involves the breaking down a large piece of the text into a smaller, meaningful units such as a sentences or paragraph. Like there is a like long paragraph. So this segmentation convert a paragraph into a some sentences kind of thing. So like here you can see this is a large paragraph. So our segmentation technique separated this large paragraph into the different sentences, like hello world, this is one sentence, this is the one sentence. And if we talk about the tokenization, what is the tokenization? Like this is a sentence. We love NLP. So tokenization, what would it done? It separate all the letters in this way. Like V is separated, love is separated, and NLP is separated, and this is also separated. This is the for the algorithm to the understand these sentences. Like there is no algorithm which can understand this sentence, so we have to split word to word. Sentences, you need to get the words in a sentence and explain them individually to our algorithm. So you break down your sentence into its constituents word and store them. This is called the tokenization, and each word is called a token. Now, the third step is the removing the stop words. What are the stop words? Like there are the some words which don't have a meaning for the machine. Like just suppose this is a sentence: geek for geeks, a computer science portal for geeks. So here a for they are not as some kind of a meaningful thing for the machine. So by in this step, these words are removed. So this is the like why we do this. Like first of all, to make our learning process faster. If there are a lots of words, so there would be the large amount of data, and it will slow your uh, learning process of the machine, and as well as it will require a high amount of resources. So that's the thing. So in this removing the stop words step, we removed the words which are not having the meaning for our work, especially. So you have to control these things. Fourth step is the stemming. Like here is the example, like consult, consultant, consulting, consultative. consultants, consulting. So these have the kind of a common word there is a consult. So for a machine, it label it as a all these words as a consult. So this is a process called the stemming. So it convert like same kind of word into a singular word. On the other hand, there is a limitization. Uh, this is the just kind of a we say the opposite of stemming. Stemming in the stemming like it split the word by using the common. Just suppose like there is example studies and studying. So if the machine see these studies and studying in the stemming, it remove the suffix or prefix uh, like it remove the IES, so it would be the STUDI, and in the this way it would be the STUDY. So, but what would the lemmatization do? Lemmatization will use the grammatical things, and it will go for the grammar things, and it convert into the words into a common word which have the some meaning. Like stemming does not go for the some meaning, but lemmatization would be go for the user grammatical rules and grammar to convert that thing into a meaningful word. Like just suppose as I told earlier, like just suppose you have a three words: be, sorry, is, are, was, am. So what would be the your stemming would not be do anything for that, but lemmatization convert that is am are into be. So it usually it's a grammatical information, and it lemmatize that word into that thing. So this is the fifth step, which is called the lemmatization. Now this is a part of speech tagging. What we do here. This is this part mainly just split the our sentence into the like it's a part of speech. Like what would be the noun, what would be the verb, what would be the adjective, what is the are the preposition here, and what are the determiners. So that's the thing which have done in this part. Then there is a very important part that is called the named entity tagging. Generally, it is called the NET. Just suppose you have removed all the part, like just suppose you have removed the stop words which are not required to you, but you have a just text like this, uh, kind of this, and you want to require it into a structured data as what was the purpose of us. So what we do here, so we have to we have to structure the data. So for that purpose, you have to introduce some classes to the machine. Like what this would be the name, this would be the class. Just suppose you have a data for which have the name, city, and this profession. So you have to make a class like this. Here it should be the name, then it should be the city of uh, that people, and it would be the profession. So this what this is called the named entity tagging. So you have to give a name for those classes. So after all the you have to introduce a just suppose here are the some example is given like your the pop-up culture references, everyday names, flagging names of movie, important personalities, location. So if you go for the data from the like any web-based system, so you have to categorize your data into this. Like just suppose you do this for by classifying the words into subcategories. Like these why you need this help you find any keywords in a sentence. The subcategories are person, location, monetary value, quantity, organization, movie. So you can make a class according to that, which you from which your data is related mainly. After performing the pre-processing step, you then give to the resultant data to a machine learning algorithm. Now you have a structured data, so you can now proceed from any algorithm, ML algorithm. But just suppose you have a data, so you have to give it to a name. So if there is a large data, so it is uh, it become a problem if you have a large data to give in the name for every class, for every subcategory. So for that purpose, there is a thing which is called the name entity recognition. In short, that is called the NER. What it do? It detect a class from the data and give it to a particular name. Like just suppose there is a name, like just suppose you have a data for the boiling point, melting point in the literature. So you have done these things and NER will recognize all the things. That would be the material. This is the melting point. This is the boiling point, and this is the some other parameter which are in the uh, data. So generally, this NER is widely used. So now I'm just introduce what is the NLP here, but how the NLP is used are using into the machine into the material science. These are some example. These are some case study. We are not going to for the hands-on tutorial for this work because it require a large amount of data, which is not possible to do on a live interactive session. So this work is entitled as a automated extraction of the synthesis parameter of pulse laser deposited material from the scientific literature, which is published by the Rajan Kumar, Avlokit Joshi, Salmani Khan, and Shikhar Mishra. And in this work, as you can see, here is a word, the pulse laser deposited material from the scientific literature. So they use a literature which have information about the pulse laser deposited materials. And they extract the information about those the synthesis parameters. Why we need this? So matter science is an interdisciplinary field focusing on the study of the materials property, compositions, behavior, design, and characterization. That's why there is a vast amount of the data which is have a high quality and which is have a its meaning. But this publication contains the valuable information, but there is a problem like accessing and analyzing this information manually is very time consuming. It's just suppose you are going to search for a sinking temperature of any material, so there are the lots of literature about that, so you are have to spend a lots of time to extract that information. Like if your synthesis required a like lots of optimization parameter, so that's why you have to go for a very vast amount of the literature. So there is a problem in this kind of thing. So now what we can do to accelerate the metal discovery, a data-driven literature-based discovery approach is needed. What is the literature-based discovery? Literature-based discovery is a means meant like how we done the things into the research. Like we first go into the literature, then we some read some papers and extract the information from that and plan our research according to that. But uh, a man has a like some limitation like it can't go for a large amount of literature, but if you have a some like just suppose you want to search anything, you go for the Google or any chat gpt and write there and it will give you the information. Like if you have some same platform kind of thing for your material research also, like just suppose you are giving to the thing like I want to synthesize this, what would be the optimization parameter for this material. So is it possible to the your model? It will give you the all the information like what would be the sinking temperature, what would be the holding time, what will be the like stoichiometric ratio you have to take. So this is called the literature based discovery. Like your model have learned from the literature. Now it gives you the information. This LBD helps the efficiently extractive and utilizing knowledge from the existing literature for the faster advancement. Now, the how can we do this? NLP is a powerful tool for the extracting and analyzing the information from the written sources like research paper and the website, as we discussed earlier. And this NLP advancement and increase the computational power have led to the development of the large language models. Like large language model, like your ChatGPT is a kind of a large language model. So this kind of platform can be introduced by using that kind of thing. There are if you see in the literature for the NLP, what the people have done for the material science, so there are some kind of uh, models, chem data extractor and chemical tagger, which are generally used to extract the information which is related to the chemical text from the literature, from the any kind text. So, but there is some kind of need to for a model which have the deep convolutional and the recurrent neural network, which can enhance its accuracy. Why it is needed? Like if you see like the chem data extractor and the chemical tagger, there are some problems in that because you have to go for a some restricted thing like it is a just suppose it is a universal kind of thing like chem data extractor, like it will use the all the chemical composition and the chemical composition and its parameter from the literature, but it due to having the having a vast kind of thing, so it is not good for a like you are just just in this work we have to go for the PLD section, PLD thing. So we have to analyze see the parameters which are needed for the uh, needed for the for the PLD process. So for that purpose, we just want a restricted values, but we need a high accuracy. But when we talk about the chem data extractor and the chemical tagger, they have a vast amount of thing, but the accuracy will be sacrificed on that thing. So for that purpose, there is a kind of thing that is called BERT, bidirectional encoder representation from the transformers. What is this BERT? BERT is a neural network model that help computer understand the context of words by considering both the preceding and the following word in a sentences. What is this kind of thing is saying? Like just suppose you have a line, you have a sentence like this is the bank of river. Okay, so there is a word bank. So your machine does not know what is the bank. Bank is the like the edge of the river or a, like the area which is at the edge of the river, or it is a like some financial thing. So for that purpose what this do, this use the like the following thing and the preceding thing, like it will read in this way like from the forward way and from the reverse way. For that by using that thing, it will relate to the river to the bank, like bank to the river. So in that way, it will understand that word. This is the river is a sorry, bank is related to the river, not the some way financial thing. So it is not show you in a mathematical way how it do, but creating contextual embedding and is trained on a large data set. Standard BERT model trained on the general text. General text means like your Wikipedia or your which is widely available on your newspaper kind of thing. So it is generally trained on that text. But what is the problem with that text? That is not related to your scientific things. So it can't be applied on your uh, material science data. So for to or any spatial data. So for that purpose, it is making some words which are the domain specific, like just bio words, cybers, and the clinical word have been trained from the specific type of literature to handle the specialized jargon better. Like just suppose if you go about the cyber, that is have some information about the scientific data and it is trained on that. And there is a biobird which is widely which is trained on the bio-related data, and you can use that library for your purpose. So now, what we have introduced some words and the things which can be used for the NLP. Now, in this work, a specialized NER model, like this is the name entity recognition. NER means model was developed to extract the data related to the pulse laser deposition technique, which use a high intensity laser to deposit material onto a substrate. This is the objective of this work. Like first of all, we have to make a some uh, name entity recognition. But So we can structure the data, like we can get a structured data. The fine-tuned MatSciBERT model demonstrated high performance in the extracting and analyzing the PLD related data. Here, this is the thing, MatSciBERT. This BERT is developed, which are you can get the information about this from the literature, which is generally trained on the material science data generally, and it is able to understand meta scientific data in a very good manner. That's why this is was used here. This In this work, data acquisition by these things like first they search the keywords pulse laser deposition, then they restrict them to go for the literature which is published into the 2000 to 2022. And when the all the literatures generally have the like some articles or the conference paper, and they restrict their subject area to the material science, and they also go for the only open access literature. And after selecting this, they got some XML file, some HTML article, and they use those things. After using this, they got some around 20,000 DOIs, which are related to the PLD research. And uh, they created they divide those articles into the things like how they related to the different publisher like Elsevier, Springer, Nature, and they classified that DOIs into this section, and then they create a publisher specific Python script to automate the article downloading. Like there is a 20,000 articles, so it is not possible to download them manually and extract the data from that. So for that purpose, they prepared a Python script for that. They downloaded the literature, and there are some 5,300 XML article, and there is some 3,600 HTML research article from which are from the 2000 to 2022. These are some workflow, how they work. Like first of all, they list the DOIs, then they create a automated article downloader, then they extracted the HTML and XML article. Then by using these HTML or XML parser, they created the some information which have uh, which paragraph have the uh, useful information which you required, and which paragraph don't have that useful information. So after that, they create a custom web scraper, retrieve the article using the DOIs, including title, authors, abstract, and the raw text file in the HTML or XML format. After that, they prepared a structural processing. XML hierarchical structure and the HTML tags were passed using a elementary Python library. What these library do? These actually extract the paragraph and what are the object like what is the your figure table, and there is some metadata. What is the metadata? Metadata is kind of a title, author's name, and these kind of things are called the metadata. And the paragraphs are separated. What are the paragraph extraction? In the paragraph extraction, they use from the XML. Uh, in the XML, they use a para tag to retrieve the paragraphs. But for which data are in the HTML form, for that purpose, they use a beautiful soap. Beautiful soap is a kind of a library which is used for the extract the data from the HTML documents. After that, they maintain quality, like how they control the quality. Like just suppose you have a paragraph into the literature, and they use some constraint to the data, like which can be removed the irrelevant data. So you have to look for the data, what kind of data you extracted, then you remove those irrelevant data, and you can give some commands by which it can remove that data. Like some white spaces. White spaces just like just suppose in this slide there is this space. So these are the called the white space. 1 minute. Is there any question? Okay.
We can choose a specifically what parameter we want
Sorry.
after collecting that. After
You
collecting
can
this data set. Hello. Yes, sir.
can you speak loudly?
After collecting data, after converting the binary form, we can choose what we want and what,
Like
from the paper what
okay,
we want.
what kind of data you needed here?
Here means we want something like temperatures, what parameters they're
I will
used.
show you into the next slide what kind of data they
Okay.
like classify.
Okay, sir.
Okay. So after that, the what would be the outcome from here? They created a structured database of the article content, improving the data set granularity and the analysis quality. What they got here? This is the pre-processing how they use like they clean the data and they make a they ensure that there is a consistency into the formatting of the data and they normalize the like the units like there are the kind of some like if you are going for the PLD, so there are some parameters like temperature, the partial pressure, and the laser, wavelength of laser, power of the laser, that kind of thing we have to tune. So there would be the some different unit for those. So for that purpose, they normalize the standardized units and for the temperature, pressure, and energy. And the entities were labeled using a annotation tool. And the like as we talked about earlier, so there is a like a name entity tagging kind of thing. So the entities are labeled using a annotation tool like a training data set for the material entity recognition model was created. So they created a kind of data from that. So what is the paragraph, sorry, embedding tool do here? Like BERT based embedding converted the text into the feature vectors. Uh, like how these things is worked. Like as we told about that, these context converted into the vectors. Like just suppose you have a data kind of thing. Like the helium has a abbreviation like He. Like is like if I talk about the F iron, so there is a Fe. But like just suppose your machine don't know about this. So how it how it create a relation between that. So it work on the vectors like the distance vector like in the literature in the text format, what is the distance between it is not a physical distance first of all. It is a distance between a vector kind of space in which all the text are embedded. So what is the distance between the helium to Fe? So helium to He. What is the distance between the iron to the Fe? What is the distance between the nickel to Ni? So they created those things and in the vector space, and according to that, they give to the information as a output. So they use a but okay. And the model from the TensorFlow was used. This is in the into the TensorFlow. This is what the things that they got by using this. A binary classification model characterize paragraph based on the processing parameter. First of all, they create a classification thing. What is the classification thing? They classify the paragraphs. Which paragraph contain the useful information or not related, which we want. So for that purpose, they label the paragraph like 0 and 1. Like this paragraph contain the useful information and this paragraph does not contain a useful information. So for that purpose, they label the 5200 paragraphs in which the 577 paragraphs contain the useful information and 4653 paragraph don't have. So first of all, they classify those things like which paragraph contains the useful information, which paragraph does not contain a useful information. Then the model was embedding by using the BERT. It was designed with the TensorFlow and the Keras framework. What the optimizer they use the Adam optimizer and the binary cross entropy loss were used to optimize the these parameters. Then they get they get some F1 score about the 0.93 for this classification. This is not about the correct for uh, as someone asked earlier about the parameters. This is not about the parameters. This is about the paragraph. First of all, they classify the paragraph which is have the processing parameter, which does not have the processing parameters. And these are some uh, labeled paragraph. These have the some useful information. This does not have a useful information. Then it embedded using through the BERT, and it gives us some information, and by using the sigmoid function and uh, sorry, and the cross entropy loss, they train this model. Now after that, now they got a very good accuracy, which is about the 0.93 in the classification of the paragraphs. Now the paragraph which have the useful information, they go for the materials entity recognition. Like as we told about, they are the name entity recognition. There is a materials entity recognition. Uh, what this do? These MER identifies and characterize the material and the parameters which are related to the PLD experiment. What are the PLD? And they use the MatSciBERT, a BERT-based model trained on the material science text was fine-tuned. What is the tuning like? Just suppose in the last classes we use a hyperparameter tuning. This is the same kind of tuning thing here. The model classified the entities such as the deposited material, what material are going to be deposited. Then there is a laser fluent. What is the energy of the laser? What are the frequency of the laser? What are the partial pressure of the oxygen? What are the substrate they are going to use? What are the temperature of the processing? What is the wavelength of the laser, and the some other parameters. So these are the classes in which the data is structured. Okay. So they created a some three kind of model. First of all, MatSciBERT, just then there is a MatSciBERT, and which is embedded by the CRF. What is the CRF? Conditional random field. I'm not going to discuss what is the conditional random fields, and what is the bidirectional long short memory with the conditional random field. So because these are the some advanced thing, because first of all you have to go for the what is the MatSciBERT, how it works, what is the math of that. So in the among all the models, I'm going to tell you, MatSciBERT CRF shows the best performance. And after the get the some classification, we have a go for the manual inspection to refine the data set. So okay. Uh, So after the classification of the paragraph, MatSciBERT extracted and organized processing parameter from the 6,000 paragraph. Then we have go for the unit normalization. As I told earlier, this is the second time which we do, because there are the at that time there is a large data set, so there would be the some uh, data does not have the same wavelength or same units. So for that purpose, we have also again use a normalization. These are the result. These results for the paragraphs. What is the result? These are the precision, recall, and the F1 score for the paragraph, which does not contain the relevant information and which contain the relevant information. And this is for the oversampling, and this is for the undersampling. Now, what is the embed parameter, structured parameter? Now, you see, this is a train model, like just suppose. Okay. Now, this is your the textual data you go from give this model from the literature. Now, this model highlight the uh, extract the useful information, like this green highlighted is the material. This blue highlighted, sorry, yellow highlighted is the energy. This violet highlighted is the temperature and the wavelength. So here you can see, and the frequency is highlighted with the this uh, kind of light violet kind of color. So here you can see this the kind of thing how it classify the data and extracted the data from the literature. This is the pressure, partial pressure. So these are some accuracy parameter like how the when the epochs number are increased, how the F1 score is increased, and this for the micro F1 score, this is for the macro F1 score, and this is the values how the your MatSciBERT CRF got the accuracy, and this is for the MatSciBERT only, and this is for the MatSciBERT BIL STM CRF. And you see here as the color of this increase from this blue to yellow, your accuracy in increase F1 score is increased. So here you can see frequencies have the higher accuracy, and for the MatSciBERT CRF has the higher accuracy among all the models. And this is the parameters like F1 score for all the models, for the energy, for the frequency, for the material, for the oxygen partial pressure, for the substrate, for the temperature, sorry, for the wavelength, what they have used, and this is the some micro F1 score, and this is the macro F1 score. What is the micro F1 score and the macro F1 score? Like here are the various things like there are the 8 parameter, sorry, 7 parameter, which are trained and which are classified by using this. So there is a thing about the micro F1 score and the macro. Macro F1 score is just the average of this. If you see this value is the average of all these parameters. But micro F1 score is not about that. Micro F1 score is calculated all the parameter like what would be the false positive of all the things, what is the false negative, what is the true positive, what is the true negative, all the data, and then it sum up of all the things, then it calculate this F1 score. So that's why it is called the micro F1 score. So this model is the handle the different labels which require the multi-class classification. For the multi-class classification, both micro and macro F1 score were calculated in this one. And the micro F1 score is a composite matrix that considers the true positive, and the false negative across all the classes. It does not go for the like what is the uh, total F1 value of for all the model. It is go for the all the values for all the model. Then it sum as a all the true positive, all the false positive, all the false negative, all the uh, true negative, and then sum up all the things and then calculate the F1 score. That is called the micro F1 score. The score treat as the task as a single multi-class problem producing a singular F1 score. But now there is a macro. The macro F1 score calculated the F1 score for each class first of all, then it averaged them. Each class is a given equal weight regardless of its prevalence in the data set. These are the some results like if you see the like classification of the data and distribution of data, like this temperature is like this kind of thing. So all the data is lies between the like 400 to 700 most of the data, and sorry. Uh, so this is the for the oxygen partial pressure, and you can see the most of the oxygen partial pressure is below than the 100, and mostly about the 0 to 25. Most of the things between this, and if we see about the laser fluence and the energy, which is mostly in the between about the 2 joule per centimeter square to the 6 joule here. Most of the data, and the laser wavelength distribution you can see it's about the like 240 most of the time, 248, which is related to the KRF Alzheimer layer laser layer. And these are the some distribution like for which parameter, which material, which is the class of the temperature, which is the class of the oxygen pressure, partial pressure, which we require. So this kind of thing, from this kind of thing, you can decide your experimental parameters. So if you see like ZNO, the temperature is around this 550. And if you talk about the temperature for the BATIO3, it is about the 700. And when we talk about the temperature for the VO2, it is about the 500. Most of the data is some plus or negative, positive and negative. And if you talk about the partial pressure for the oxygen, here you can see from all the things, it is about the 0 to 20. But if you see the ZNO, it is largely on the about the 5, but BATIO3, it is a very sharp value about the 5. It is not beyond that. But if you see about the VO2, it's at a wide range, it is 0 to 40, it has a kind of use. So by using these things, you can design your experiment by using this literature-based discovery. And what are the conclusion from this work? If you see, this work is use the MatSciBERT CRF model, which shows the best performance overall. The MatSciBERT VILSTM model was the second best performer. If you see the evolution parameters. And the distribution, the normalized extracted parameter provide the insight into the PLD experiment. So these insights you can get the which parameter you have to use for this PLD of your material. And this data set will assist in the selecting the appropriate deposition parameter for the various parameter also. This study successfully applied a large language model to extract the processing parameter for a thin film deposition because we do the PLD experiment for the thin film deposition. And the MatSciBERT model was fine-tuned on the PLD scientific literature here. And the data quality was ensured through the outliers removed and the unit normalization is done by using some manually, and some things are used by using the Python. The model accurately extracted and categorize the parameter like deposition, temperature, pressure, laser fluence, and the wavelength. As we have seen the some example here. These insights are expected to the advance the material research, the facilitate future discoveries in the thin film deposition using PLD. So we can do these things, and so. Is from my side. If you have any question about this, then after few minutes we will discuss some other paper which is also about this.
So I missed something related to signal problem. How can we
Sorry.
fix the model? Some this part because of I'm in the train. I have some network issues. I have a doubt. How can we fix? How can we fix the model? Which model it can be suits to us? Saying the model.
Which model will be suited for our data, I think.
Yeah, match, but CRF. You are saying match,
Actually,
but
MatSciBERT. Okay. That depend on the which library is trained on which kind of data. If I talk about the SciBERT, it is widely trained on the scientific kind of data. But when it is converted into the MatSciBERT, it is trained on to the largely trained on the material science based data. So this problem is about the material science, and we required some materials related things, and as well as some uh, physical parameters thing. So that's why we use this model.
why
MatSciBERT.
CRF? Why CRF? But CRF.
CRF, this kind of thing just suppose just for example you tune your model by using some other thing as this what kind of thing here. Like here they use some CRF and BILSTM CRF. This is the some extended version of this library. They use the MatSciBERT, but they also used by using this other technique also. So to ensure the accuracy. of the model. So these are the some extra things like because you can tune your model according to your your like what you want. According to that, you can change.
Okay, after getting it out, which parameters is better, it will be shown like that.
Sorry.
Which parameters is mostly used, it will give that data, right? After
Actually,
final.
generally, MatSciBERT is used. Okay, but if you are not to get a so just suppose you use the MatSciBERT on your data, but you are not getting a high accuracy. First of all, what you will do, you will try to tune your model. You are going to tune your model, but like just suppose I'm not getting a accuracy. I'm not satisfied this accuracy. So what I can do, just suppose extend this model. So I will try the different algorithm and on this MatSciBERT and got the a good accuracy. So that's the thing how work they work. Maybe I'm able to answer your question.
Yeah, if we not got any good accuracy means we can try and use another algorithm, mixing those algorithms, and we can
Yeah,
get
yeah, yeah. Well,
good accuracy.
just, just because we have to optimize the things.
How many maximum there is?
Sometimes
How many models are there?
maybe models are there are a lots of model in today time because people are publishing a different kind of model day by day.
Where
So
we can get
there is
this?
a okay.
Where
Sorry.
we can where we can get these models?
You can get this model from the literature some of people uploading those model into the kind of thing like GitHub or some have used this model as a like library, so you have to install that library.
Normally if we go into the Google Scholars and we'll see elsewhere papers being there. Though from those papers it will be not.
Sure, you can also search on the GitHub. GitHub is a kind of thing where people share their codes what they have wrote for that library for that purpose like for some different kind of model.
GitHub it will be easy to access that models.
It
That
is
paper.
easy. GitHub is open access. Is there any other question? Okay, let's wait about for the 10 minutes. Then we will be back and we will start about the next paper, which is again is related to the NLP. Uh, Maybe some other understanding you will get from that paper. So please wait the 10 minutes. Then we will again start. Hello. Let's start about the from the next work, which is about natural language processing algorithm for domain specific data extraction in the material science. In the previously we have discussed about the libraries. We have used MatSciBERT in the last work. So this is about the what kind of library you can also develop for your work, and you can also contribute to the community in the by producing any library for a particular domain. So this is the same way. In this work, these people uh, make an algorithm by combining different things. So these what is the motivation behind that? The scientists distill the scientific text into the new research article, often leading to a redundant work due to the insufficient time and resources. Uh, Nowadays, researchers frequently replicate the existing work, leading to the wasted effort, and they could avoid it with more the structured and accessible research format. If I have a structured work, so I can search there, and I can restrict myself to that thing. So what is our natural language processing? As we have discussed, help us converting the unstructured text into the structured data set, which can the boost the productivity of our scientific community. There are a lots of tools like OpenAI, GPT, Google Scholar, and PubMed, which are generally used to process the scientific text. But many use generic data set that have the limit domain specific understanding. We have not access that like lots of data are still in the PDF format. You can't do that text. You can get the text from that. So that's the motivation behind that. Domain specific NLP models such as earlier CAM data extract and the MatSciBERT face the limitation due to their dependency on the quality of OCR engine output and the challenges of varied document formats. What is this? Most of the data is depend on model are depend on the OCR engine. What are the OCR engine like? Maybe many of you uh, click the photo of anything by using the Google scanner. So when you click the photo of any text and it will convert into the some text you can copy and paste anywhere. So that's the thing which is called the OCR. And why it faces challenges, like it requires a lot of time, but also there are the challenges of very document format. There are the various type of format of the documents. There are a lots of kind of paper format, literature format that we have. Like just suppose Elsevier published the article in a different format. If I talk about the Nature that published the later data in a other format. So there are a different kind of format. Due to that, there is a uh, problem. So generally PDFs are used for the research articles, and which have a different kind of layout and inconsistent formatting. So that's the thing they face the problem. Existing OCR engine like Tesseract and Google Cloud Vision struggle with the varied for fonts and design impact, and which impact their accuracy of the extracting the information. There's the problem. Neural network and the deep learning model are employed to handle the unstructured data, but researchers often find customizing data set and the models challenging. Like you can go for the machine learning model, but first of all you need a uh, good data. A new customizable NLP algorithm is proposed in this work, which focused on the domain-specific research by scoring the text relevancy based on the title, abstract, and the conclusion from the PDF. So here they develop a NLP algorithm, and the algorithm aim to improve document image analysis, information extraction, and the specialized output format while leveraging the existing NLP tools to avoid the redundant features. So what they have work, they try to increase the accuracy as well as they try to avoid the redundant features. So that's the way they work here. And Methodology, they first of all collect the documents and they do the layout parsing for all the literature. And what they have done in this, they remove the white spacing algorithm and some other parsing tool. Then they pre-processing their data, and just like as we told earlier, every NLP algorithm is depend on the like text cleaning, tokenization, lemmonization, etc. And after that, they make a corpus. Then they classify the information like by using the relevancy score. After that, they extract the information from the experimental data and it create a output file, and that's the thing they do. Uh, what they have do in the data collection extraction. The tool extract the text from the PDF while preserving the cementing figures and the tables. The steps include the document collection, decluttering, and cleaning, text processing, extraction, classification, and structured output.
Sir, you are showing PPT, sir.
Huh? Yes.
It's
Are
not visible.
you not able
It's
to
not visible.
see this?
PPT, sir. Yes, sir.
Oh, you are not able to see my PPT.
Yeah, yes.
Are you able to? Why you not tell me this earlier? Yeah. 1 minute. What you are like? What are the visible on the screen till now?
It's not with your mic or something. Your voice only. You are saying something. We are now you are explaining that way. We have known about you are showing PPT. You're thinking like that.
Yes, I am
Nothing at all.
actually. Are you able to see my screen now?
No. Yes, sir. No, it is.
Okay. So you have not say anything earlier, so I have to go for that.
Yeah, yes.
Okay.
Yeah.
So so I have started from this work. Now you are able to see the screen. Hello.
Yes, sir. Yes, sir.
Okay. If you face like if my screen is not showing to you or my voice is not audible, so please tell me in the between. Okay. Now. So this is the second work which is based on the NLP. In this work, actually they prepared a natural language processing algorithm for the domain specific data extraction in the material science, which they named as a dis disrector. This work is done by the Antakrate and Divyansh Mittal, Ojasi, and the Professor Shekhar Krishan Jha. And in this work, the motivation behind this work is about like there is a lots of data is still in the form of the PDF. And if I talk about the PDF, there is a like a different kind of formatting for all the uh, publishers, and they have a different kind of fonts. So these problems are by using this due to this kind of data, our models like CAM data extractor and the MatSciBERT face a problem because they are based on the OCR engines, just like the Tesseract and the Google Cloud Vision, and they find struggles in when the fonts are varied and the design of the things are varied. So that's why these people work on this, and they try to give a new algorithm. So they prepared a customizable NLP algorithm, which focused on the domain specific research and are we, which such by scoring the text relevancy based on the titles, abstract, and the conclusion from the PDFs. And the algorithm aim to improvise the document image analysis, information extraction, and the specialized output format, while leveraging the existing NLP tools and avoid the redundant feature. So here they try to do try to do two things. First of all, they try to leverage the existing NLP models, but they are also try to avoid the redundant features. Like in that PDF, like you can see there is a lots of white space. So they try to remove that, those kind of thing. Uh, so this is the methodology they used. Like first of all, they collect some documents, then they try to create a layout parsing in which they see the what is the white space, and then they pre-process their text by using the some NLP things like text cleaning, spell check, tokenization, lemmatization, and they create a corpus after that. Then they classify the information and they get their relevancy score. And after that, they extract the information from the literature and they create a output file. The what they do, the tool extract the text from the PDF while preserving the semantic figures and the tables. Steps including the document collection, decluttering, cleaning, text processing, extraction, classification, and structured output. So this is the flow chart. And database, how they prepare the database. First of all, they have collect the data by using the some web scraping or the direct upload from the in this work they have downloaded the 70 paper using the keywords like hydro hydroxy appetite and NLP and biomaterials. So they downloaded the 70 paper and the paper was split it into the two parts. First of all, train and then the testing for for the testing part for the evaluation of their model. And the initial step, they steps are developed for a single research article and refined through the iterative testing. So first of all, they prepare the model for the one article, then they refine using a iterative testing. Like they use the many papers. First of all, they do the identify text, image, and table in the PDF, which require the OCR technology, and they then try the layout parsing depends on the efficiency of the OCR engine with an example shown on the Tesseract. Maybe I will show you that. So then after that, they see the two layout parsers. First of all, that is a white space, and the other thing is a layout parser. What is the white space algorithm? White space algorithm just check the what are the white space into the PDF. Like just suppose uh, as you are seeing my slide, this is the white space here. Like this space does not contain any word, text, etc. This is the white space. This is the white space. This is the white space, and this is also the white space. So this white space algorithm work on that. Like it highlight the what are the white space, and in the final that remove those white space from the final text. And what is a layout parser? These parser actually detect the words and the image and table. What are the image? Like it is the reverse of the white space kind of thing. So they use a combined approach using the both tool improves the layout detection and the text extraction quality. So I will show you that. Like just suppose this is the original image, then the it create a adaptive binarization, then it do the component analysis phase. Then it create a words detection paragraph line, and it create a two-step recognition, and it get a text document. So this is the like kind of the flow chart how they work. This is the for the white space algorithm. How they do that? They start with the document like they give the document image for the text extraction. Then it iterate through the each row of the image. Then it detect the layout coordinates of the document image. Then the ECR, sorry, it is for the tesseract. Then the OCR engine tesseract run, and it give the text recognition in the detected layout blocks, and it is stored into the dictionary with a different ID for each article, and it's end. And this is the processing, which this is the post processing. And what the things done here in the iteration, it check the multiple component columns check for the multi, divide into the image region based on the column, store the white space till a black pixel is the encounter. Like everything, just suppose everything is it create a column and it make out the white space until that it find a black pixel. So just suppose it run through this and it hit about this black pixel. So it get like it is not a white space. So this is the all the white space about that. So that's the way how this work. And the same way then there is a sorry. This is the layout parser. What how the layout parser work? It is start as a on the same the document. It detect the blocks of the documents and image. Then the OCR engine work. It is Tesseract and the work on the Google Cloud Vision. Then it recognize the text in the detected layout blocks and it store and visualize that and it's the end. How they work? So now I have to show you the paper. Uh, if you are using a data from the any literature, so you have to mention that in the final publication. You can use that because it is if you, that data is open access. Otherwise, you have to get a permission from the like who published that. Okay. Now see the things. Now I have that image. Okay, sorry, this is the image. Ah, this is the layout parser. It detect where is the text, where is the title, where is the single column kind of thing. And this is the tesseract which detect where is the text only and where is the images. But when we talk about the white space algorithm, it see where is the white space and it work until it find a uh, black pixel. So after the pre-processing, they ensure the accuracy by correcting the errors and maintaining the semantic meaning. And the pre-processing include the spell checking, cleaning, filtering, tokenization, and elimination was done. And using the NLTK for the text and the corpus, they use pre-processing. And what how they develop a corpus? They three categories of corpus are used. General corpus, which have the English Wikipedia and book corpus for the basic word filtering, and then they use a domain-specific corpus, which includes the scientific text, material, and the science-based dictionaries. And the third corpus, which is the customized corpus, and this was defined by the user to define the domain specific relevance. Like just suppose there are some new words which are not present into the domain specific or any general corpus, so you have to customize that corpus. And after that, the raw text input are filtered through the this corpus to enhance the accuracy. Like all the three corpus are done. For example, corpus included the brown corpus, domain specific scientific test, and the user defined keywords. Uh, okay. Now you, if you see this, are you see, are you able to see my screen? Okay, this is the corpus. Like here you can see the raw text into the PDF. From the PDF they extracted. This is the basic English, and they have the some kind of these words, and these are the some meta science based words, and these are the some customized they created by manually, and they prepare some lemmatization from this corpus, and they give it to the NER, which is the name entity recognition from by using this corpus, and they created a vector database, and they also checked by using the grammar also. After that, what they have done, they have created an input, then they do the sentence tokenization, then they give the word tokenization. After that, they do the spell checking. They applied a padding, and they rule based labeling. This is if you are going for a particular keyword, and after that they get a final training data. So this is the overall. This is the overall flow chart how they using this word processing and do the things. And after that, by using these three things, name entity recognition by using combining these corpus, they get this kind of score, like star relation matrices. So they use a F beta and F1 score, and this is the precision score they got by combining the these things. This is the from the layout parser. This is from the normal OCR. This is from the white space algorithm, and this is the restrictor, which is combined from the white space and which is from plus layout parser. And if you can see, the F1 is accuracy score is highest for this combining thing. And if you see about the F1 score, which is also high for this in among the all the things, recall, precision, and over. And by combining these things, they prepare a kind of just suppose in the first paper, someone asked me how to make a algorithm and how can you tune your model according to that. So this is the way you can tune, and these are the evaluation matrices which they have given. And you can see here, this is the normal text, and this is the word token, and then they get the useful information from that text, like collagen CSUL2 solution 2.8 ml 0.1. So you can get some scientific data which we needed. So this is the F1 score, and okay, I can show you something. One. Are you able to see my screen? Okay, see this. So here they created a user interface based platform in which they loaded a article and they like what they are trying to search term.
Those words are preferences.
Sorry.
There's process titanium iron leads. Those are the preference things from that paper we choosing the.
Sorry, 1 minute. Can you repeat what you are saying? Hello.
There you said they're taking the process. They're taking processes titanium iron leads. These are the
Yes.
uh, preferences. Preferences
So it
in that
chooses
paper
those
about this.
words. Yes. Like it want to search like what they want to search from that article. So like here you can see they found like a particle size which statements are like about to the titanium and about the lead, about the iron, which they select there. So they got this thing particle size 20 nanometers, solvothermal, purity TiO 99%, SCl purity product 99.3, TiO2 approximately 95 to 98% TI, and so this kind of information they got from that text they uploaded here in the PDF file. So this is the thing they work. So, and they prepared this platform. You can also go for their GitHub repository to get a more insights what they have performed.
They, they have kept it. What data came? They have kept in paper.
Sorry.
Something. Result was came right. Result was came right.
Yeah.
That result where they kept that result.
Actually, can you write your question into the chat box? Are you writing your question? Actually, I'm not able to hear you like, clearly.
Yes, sir. Yes, sir. I'm writing it.
Okay, let's try. Where it can be used. So for that purpose, you have to go for their GitHub repository, and if you want the more information about that, you can mail the corresponding author as they wrote there. Okay. Otherwise, you can also prepare your model according to that yourself. Is there any other question about the NLP and how the things? Can you show that even the US collecting paper you use in order to find what your parameter like energy gap? We can see the example in the stepwise in the proper manner. Like you want some like hands-on tutorial kind of thing.
Yeah, yes, sir. Yes, sir. Yes.
But in this work, actually, for the like NLP things and for the image segmentation, it is not feasible. And the last time we got stuck.
Okay, sir.
That's why I'm not choose that. I can do for the like for the structured data that would be done.
Okay, sir.
Okay. Otherwise, I will go for that because the NLP and image segmentation and some image processing example I will show you, and after that I will go for that. By the way,
Yes.
you can uh, you can sorry.
Your lecture I'm saying.
Otherwise, you can go for the lecture. I think live interactive session from 3 to 5. There are the some practical example. You can go for that, and I have also shared to share the data with you for the classification and the for regression. So, final question: can you do a weather relation in the level relation in the jars and personal platform? Actually, I was writing. You can do there, but maybe sometimes you can get some problem anywhere in Google Colab also. So that's not a guarantee. Maybe you are doing something wrong. That's why you're getting some error. Okay. I was. Are you getting a result there in the just? You can use any platform. There is a no restriction about that. But there's a limitation in the online platform that you can't deal with the large data set. For normal one, you can do that. Maybe in the multi-level, you need a high RAM. That's the problem. I think it shows the error like your RAM is not enough. So for that purpose, please use your PC. Like in your PC, you can use a Jupyter. Otherwise, you have to take some premium version of the Google Colab or any other platform. So they give you the some extended RAM. So you can do your work. Otherwise, it would be good if you install the Jupyter in your PC for any ML work because every time otherwise you have to load your data. If you are working in the Jupyter, there is a no such problem will happen, or you can do in the absence of network also. Is there any other question? Okay. Uh, if you guys don't have any other question, so we can end the session. Okay. Thank you, everyone. Someone told me that he will share some paper to me for the future sessions. Ishwar, are you?
No, sir, I am a student. No,
Okay. Actually, someone told me that. That's why I'm asking.
I've recently joined in a CSR project association. I'm trying to
Okay,
work on
maybe.
that. Because of after you're saying this NLP only, I can use that paper, so many papers.
Okay. Okay. Then, thank you so much. Let's meet into the next session next Saturday, the same time, 6 p.m. Okay. Bye bye.